Another typical situation is when you have not just one single sample, but when you have two samples, two paired samples. So when we say paired samples, this usually means before and after. So we measure the same value for the same objects, but in two different situations, in two different conditions. So usually this is before and after, like, for example, weights of a group of people before physical training and after physical training, or incomes or salaries of some people before the college and after they have finished the college, for example, and so on. So you want to understand how something changes the value you are measuring. And that is why you measure this value before this factor that is supposed to affect the measured value somehow, and after. And so you are interested in difference. So you want to construct the confidence interval for the difference of the average value before μx and the average value after μy. So you actually do the same that was done in previous case. So you see the same formula as here, but for x bar and s, you have d bar and sd that are sample mean and sample variance for the sample of differences. So you for each observation, you calculate the difference of x and y, so difference of what was before and what was after. And so after this sample of differences, d1, dn, is calculated, so then you find the sample mean, then you find the sample variance, and you substitute them to the same formula. So with the quantiles of the student distribution and so on. So, and that is how you can find confidence interval for the difference of means of two paired samples. So now let's find a confidence interval for a situation when we have two paired samples and we want to estimate with an interval difference in means. So the problem is that there is a training program, a new training program designed for especially for 100-meter runners. And so they participate in a run before this program, before the start of this program and after completing this training program. And there is a sample of 9 athletes, 9 runners, and their results are given, so before the training program and after. So results in seconds. So the results are before 12.5, 9.6, 10.0, 11.3, 9.9, 11.3, 10.5, 10.6, and 12.0. So these are results before, and these are the results of the same athletes after completing the training program. So 12.3, 10.0, 9.8, 9.8, 11.4, 9.9, 11.0, then 10.8, 10.3, and 12.1. So these are the results, and so they ask us for the 80% confidence interval. So 80% confidence interval for the difference in means before and after for mu x minus mu y, where mu x is the mean value before and mu y is mean value after. So mean value of the first sample and mean value of the second one. Okay, so the first, I have a misspelling here, after. The first step is to calculate differences. So these are x's, these are y's, and so we are to find differences. So I have 0.2 minus 0.4, 0.2 minus 0.1, 0, 0.3 minus 0.3, 0.3 and minus 0.1. So these are the differences, and then we do just the same thing we have already done in previous example for this sample. So the only difference is that we are to find the sample of differences before constructing the confidence interval. So sample mean for the sample of differences, d bar is, so we have 9 observations, 1 over 9, and here I have 0.2 minus 0.4 plus 0.2 minus 0.1 plus 0 plus 0.3 minus 0.3 plus 0.3 minus 0.1. And all this is equal to 0.011. So this is the sample mean. Then sample variance for the sample of differences. So mean average sum of squares minus squared average, squared mean. So here I have 0.2 squared plus 0.4 squared plus 0.2 squared plus 0.1 squared plus 0 squared plus 0.3 squared plus 0.3 squared plus 0.3 squared plus 0.1 squared minus squared mean, so 0.011 squared. So, and if I do all necessary calculations, this will be 0.094 approximately. And for the confidence interval, I need not the s itself, but not the s squared, but s. So square root of this. So SD is square root of 0.094 and is approximately equal to 0.307. So then what I also need for the to construct the confidence interval, I also need the quantile and I need I need to understand the level of the quantile. So as I'm asked to find the 80% confidence interval, that means that 1 minus alpha is 0.8, and this means that alpha is 0.2, and alpha over 2 is 0.1, and 1 minus alpha over 2 is 0.9. So I need, for the confidence interval, I will need the quantile of the student's distribution with 8 degrees of freedom, 9 minus 1. 9 is the sample size. I have 9 observations with 8 degrees of freedom of the level 0.9. I am to look to the table for this quantile, and it is equal to 1.397. So now I can substitute all this to the formula of the confidence interval. So I say that probability that difference of means is from the sample mean, that is 0.011, minus sample variance divided by the square root of the sample size. So 0.307 divided by the square root of the sample size of 9 times the quantile. The quantile is 1.397. So that mu x minus mu y is 0.011 plus the same value. So the probability that mu x minus mu y is in this interval is 0.8, as we are constructing 80% confidence interval. So, and now the only step is to simplify these numerical values. So if we simplify this, we'll get that this is equal to 0.143. So and finally this left endpoint of the interval is minus 0.132, and the right endpoint is plus 0.154. So finally we have that this is from minus 0.132 to plus 0.154. So this is the answer. So we can say that this training program seems to be of no effectiveness, not so very effective, as we see that average, so sample mean for the difference before and after is almost zero. So it is positive, yes, but it is less than 0.0. So it's about 1/100, and so as like 11 microseconds. And here we see that, so with high probability, real difference before and after is in this interval, and so the interval, as we see, is almost symmetrical with respect to zero. So maybe with high probability, a real value of this difference can be even negative. So that means that the program so even makes the situation worse, not better. So this is the example.